Hello, and thank you for tuning in to this episode of ProcessMiner University, a podcast series designed to educate listeners on technology trends driving process improvements from the factory floor to the C-suite. In today's podcast, you will learn about process monitoring approaches driving Industry 4.0, limitations of standard process monitoring approaches, and why data is the major difference between Industry 3.0 and Industry 4.0. Now, a quick introduction to today's speakers. Dr. Bill Woodall is Professor Emeritus of Statistics at Virginia Tech, a former editor of the Journal of Quality Technology, and a lifetime associate editor of Technometrics. He will be speaking with Dr. Kamran Paynabar, co-founder and chief of data science at ProcessMiner. Paynabar is also associate professor at Georgia Tech H. Milton School of Industrial Systems Engineering. Bill and Kamran, take it away.
Well, thank you, Tom, for inviting us and for the introduction. Bill, I'm glad that we have this opportunity to talk about process monitoring challenges in Industry 4.0. But let's just start with some historical background about process monitoring and control charts.
I'll be glad to do that. Statistical process monitoring is one of my favorite topics. I'm very happy to be here and to have a chance to be on this podcast. The basic ideas of process monitoring go back to the 1920s and 30s with Walter Shewhart, and he was among the first, if not the first person to realize the importance of considering the time order of data. He saw the value of information based on the time order of data. He came up with methods for anomaly detection, and his main goal was to separate the normal variation, the common cause variation that would be expected in the process, from the assignable cause, which was unusual variation that could be removed, with the overall goal of trying to reduce the variation in the process and get the process on target. So his methods are still widely used. They're taught in Six Sigma programs. They've been extended to other more complicated types of applications. But Shewhart's methods were developed in Industry 2.0 after the introduction of electricity and in mass production and assembly lines. But in Industry 3.0, which started around 1970, things were more automated. We had more data. We had more complications. The data were collected much more often, which resulted in autocorrelation. So time series methods became useful. Instead of just normal random samples, we often had functional data, and which led to profile monitoring. And also, manufacturing processes tend to be multi-stage, where the output of one process is the input of another. And so there's multi-stage monitoring that was also developed in Industry 3.0. So I would say that in Industry 2.0, 3.0, 4.0, one big difference is the increasing amount of data. And in Industry 4.0, things have really skyrocketed, and we have a tremendous amount of data. So, Kamran, you've had experience in Industry 4.0. What would you say about that?
Sure. Thank you, Bill. I think you're completely right. The main difference between Industry 3.0 and 4.0 is data. And Industry 3.0, as you mentioned, was mainly focused on process automation. But in Industry 4.0, with the help of technological advancements in sensing, communication, computation, and cyber physical systems, data collection, data transfer, and data storage has become much more easier. So like all the things together created an environment that we need to deal with high volume, high dimensional data with a high variety. As you mentioned, for example, we could have image data, we could have sensors data, functional data, and even text or non-structured data. And all of these are being collected in near real time. And at first thought, we may look at it and say, oh, that's good, because this is a fantastic opportunity for process monitoring. We have a lot of data, so we can use and have a good process improvement. But the problem is, and the main question is, what should we do with this data? How can we analyze this massive and high variety of data on the fly? Because that's also important. The speed of the data collection is high. We want to analyze it as close to real time to detect process changes and find root causes. And with this massive of data, detecting a change, it's similar to like finding a needle in the haystack. So these are challenging questions that we need to answer. And I doubt that traditional process monitoring can address all of them, the ones that we used before. With the help of a build based on what we had before and create new process monitoring and analytical tools for change detection using this massive data.
Well, I agree. What we've done in the past is certainly not going to work in some cases with this massive amount of data. One issue with Schuhart's method and with control charts is that signals result from the statistical significance of a process change. If there's been a change in the process, regardless of how small, if it's unlikely to have occurred by chance, then the control chart is going to signal. But with massive amounts of data, we're going to be detecting changes that may not be of practical importance. So I think it's very important to tune our process monitoring to the application at hand. In fact, any alarm system, I believe, has to be tuned. From smoke alarms, car alarms, any kind of alarm system needs to be tuned to the situation at hand. And I'll just give one example. In our condominium building, we got an announcement saying that we were going to have new smoke alarms installed into our condos. And the advantage is that they're going to be less sensitive, not more sensitive. So one issue with the development of methods in Industry 3.0 has been that we tried to develop methods that are increasingly sensitive to smaller and smaller changes in our process. But I think we're going to have to back off of that and ask ourselves, what is a practical change? And signal those changes, not just signal things that are statistically significant, but also things that are practically significant.
So what do you think of multivariate control charts and like the traditional one that are used like T-squared, whether they're going to be useful here or not?
Well, multivariate control charts were developed back in the 50s. I mean, some of them were developed even in Industry 2.0, but a lot more work was done in Industry 3.0. I think there's some issues with the multivariate control charts. For one thing, they assume that you have vectors of observations arriving on a regular basis. So that would mean that the sampling frequencies are going to be the same for the variables that you're trying to monitor, which is frequently not the case. Also, many of these multivariate methods are based on the assumption of multivariate normality, which becomes less and less realistic as you're looking at more and more variables. So I think that the multivariate methods definitely have to be extended and expanded. Usually they're based on only quality variables and not putting in process variables. I think that we need methods that incorporate both process variables and quality variables. But it makes the analysis very complicated. The process variables could have a delayed effect on the quality variables. Quality variables aren't measured as often as process variables. There are a lot of practical issues in trying to realistically monitor a complicated process.
Yeah, I agree. I'd like to pick up on this multivariate issue as well. There are also other things which makes the process monitoring for multi-stream data more complicated. First of all, there are, because of, again, thanks to this sort of advancement in sensing technologies, you have you may have hundreds of sensors monitoring different parts of the process, different process variables. So how you deal with this high dimensional data or multi-stream data? And the reason is why this becomes challenging, because usually only a small subset of these variables change because of some problems in the process. And if you try to monitor hundreds or thousands of variables at the same time, if only a few variables are changing, the amount of signal that you get is going to be very small. If you want to fuse the data, and then based on fused data, you want to detect the signal, the chance would be much smaller, because most of variables are in control state or normal state. So that's another thing would be, okay, would it be possible for me to sort of do some sort of variable selection in a dynamic way? This is really important. It means that can I screen at each time, can I screen the variables and just focus on those which are more susceptible to change, or more suspicious variables. So in that case, by throwing out some normal variables or unchanged variables, I can increase the detection power. So that's one of the problems for dealing with multi-stream data. Another thing that we realized by basically when we were doing like working with the customer is the dynamic or inherent dynamic of the process, meaning that you cannot have a clean baseline. In the short control charts or classical process monitoring, you have a data and you say, okay, this is the baseline that I have. You create your decision process based on that clean data, and then use this decision, the decision criterion or control limits to monitor the process online. Now, this is not valid in most of current processes, because the processes are mostly dynamic, meaning that the baseline right now is not valid even tomorrow or even in the afternoon if your baseline is in the morning. That's because the process dynamically changing, but that change is inherent change. It's part of the process. It's not because of an assignable cost. So that again makes the finding a baseline or control limits or decision making for change detection much more difficult. And the third thing here is the spatial temporal correlation and behavior of the data. So the sensors are highly correlated, and as you mentioned earlier, over time there is autocorrelation because of the significant increase in sampling frequency. And that spatial temporal behavior or correlation in the data makes it much more challenging to analyze the data, because we need to consider this relationship in order to be able to model the data correctly and do an effective process monitoring.
Well, I agree. There are many complications. It seems like to me that in order to solve these problems, it's going to be taking more of a collaborative effort than an industry 2.0 or industry 3.0. I think that the process owner or the process expert is going to need input from quality engineers, but also from computer scientists and others. It's going to have to be more of a team effort than we've seen sometimes in the past to solve all these difficult problems. So I think also we're going to have to rely more on software. That there's more of the use of software in Industry 3.0, but I think the software is going to be much more required in Industry 4.0, and the software is going to be much more complex because the methods that are going to be required are going to be more complex. Mm-hmm. So it's going to be a challenging time.
And I agree. So some of these challenges, honestly, there are still challenging question or research topics at the university level. Still like scholars in that area are working on that. We are working you work on these problems, I work on these problems at the university, but some part of it also is practical problem. For example, when we talk about multivariate data or multi-stream data, one thing which is really important in practice, and here in ProcessMiner we face it every day, is the data quality. Because we talk about like a lot of data, but not the data are not clean. So you have a lot of missing data. You have corrupted sensor is down, and you get some sensor data sometimes, or truncated data. So how you deal with these practical issues with the data quality, corrupted data, is also an important problem that we need to deal with every day before we start thinking about developing methodology for process monitoring, because you need to have a good data to be able to do the process monitoring. And this is something that we in ProcessMiner also do every day, and created some solutions for that as well, to deal with the data quality and make sure the data is ready for analysis.
Well, I have to say here that I'm lucky that I spent my career in Industry 3.0, and I'm turning. Some of these challenges are going to have to be solved by you. The newer generation, I think, in Industry 4.0, it's definitely going to be a different ball game.
Yeah, of course, it's going to be very difficult, and I think there are a lot of, as we discussed today, there are a lot of both interesting research questions as well as practical problems that we need to attack. I think today we tried to mainly discuss the challenges here, but probably at some other time we can talk about some of the solutions that are out there, or offered for solving these challenges, and at the research level, and also practical level, or the solutions that we provided in ProcessMiner platform. We can talk about that at another time.
I certainly enjoyed our conversation.
Thank you very much. I enjoyed the conversation as well. Thanks for sharing your experience, Bill.
Thank you, Kamran and Bill, for sharing your knowledge and thought-provoking insights on process monitoring approaches driving smart factories. Be sure to tune in for the next episode of ProcessMiner University, How to Get More ROI from Your Factory Data. I'll sit down with Doug Woods, president of the Association for Manufacturing Technology and lifelong manufacturing technology leader. Doug's passion for the industry began when he was an apprentice toolmaker and progressed as he held positions in manufacturing engineering, quality management, operations, product development, and sales. Be sure to tune in for this not-to-miss episode. In the meantime, stay safe and innovate boldly.